Okay, so we are going to simplify. So for number 1, you need to know how to A, simplify radicals, B, combine like terms involving radicals, and C, you might need to know how to multiply radicals. So like everything from sections 1 through 1 and 2, like 1 and 2. So make sure you know how to do stuff for 1 and 2. So the first radical is already simplified. I can't really do anything with 2 root 3, but 4 root 108 probably can be simplified.
9 and 12.
So what I'm going to do is make a little factor tree and see if I can take any groups of 2 out because they're square roots.
I would have never written down 2, 9, 12.
He said 9 and 12, so I just went with it.
That's one of the. Isn't that one of the ones that are just kind of doing?
Yeah.
You know,
So we seem to have a group of 2 3s and a group of 2 2s, and there's a leftover 3. The group of 3s is gonna go outside with the group of 2s, and there is a 4 out there, and that's gonna hang out with those guys too. And so when you multiply all that together, you get 4 times 2 is 8, 4 times 3 is 24, and then the leftover 3.
Wait, what's the 4 for?
4 was in the question.
Yeah, I know that.
Oh.
Oh, I don't know that, but now I do, because I looked up.
Okay.
My bad.
Square root of 72. We're gonna do the same thing.
72, 9 and 8. Nice.
Looks like we got another group of 2s, group of 3s, and a leftover 2. We're going to take the 3, we're going to take the 2, we're going to combine them and get 6 root 2. Okay, last one is the square root of 18.
Try that.
Looks like we got a group of 3s. Take the 3s out, they're going to go hang out with the little 5 over here. So that's going to be negative 15 root 2. Yeah, 2. Okay. Now once you simplify everything, you're going to see if you can combine anything. So anything that has the same index and the same radicand, you could probably add. So we can add these 2 together, and we can add these 2 together. So 2 plus 24 is 26. So we have 26 square root of 3, and 6 minus 15 is negative 9 square roots of 2. Can't do anything to combine those, so you're done.
Yeah, got it.
Questions?
Just, can you not erase it real quick?
I don't erase.
Oh, okay.
Alright, and then number 2, you're going to have some sort of rationalizing the denominator. So just make sure you go back, look at all the different kinds of denominators that we've rationalized. So this is a square root of 18. Now you can either try to simplify the square root of 18 and then rationalize, or you can just rationalize right away. It's up to you. For me, I think it might be easier if we simplify the square root of 18 before we try to rationalize, just because it'll make the numbers smaller. So we did this one already, right? Square root of 18 is 3 root 2. So I'm going to rewrite that as
9 root.
9 root 2. Yeah.
They read something really wrong. So like when you have like the
There's
negative
lots
6,
of ways you can do it.
Can you like simplify the negative 6 and 3 though?
Yeah, you can.
You can?
I could have probably done that. So if you want to do that first, right, and then do the 3 root 2, you could do that.
Oh. Okay, see I like that better.
Or you could do what I did and then simplify.
But I forgot if you can like simplify
Yeah,
the
you
9
can,
is attached
'cause-
to the right.
You just wouldn't be able to do it if it said like 3 plus the square root of 18. You wouldn't be able to do that.
Yeah.
So if it was like this, you can't simplify this. But if you simplify this first, then you could cancel these 3.
All 3 of them?
Well, you could cancel a 3 from each, so it'd be this. That. So that's good. Okay, so now I have a square root of 2, which is much smaller than the square root of 18 and easier to rationalize. So I'm going to multiply by the square root of 2 over the square root of 2 to rationalize the denominator so that I have a rational denominator. This is going to give me negative 2 root 2 over 3 times 2. Now you can combine your 3 and the 2 to get 6, or I can just cancel the 2 because it's going to cancel. And now I have the negative square root of 2 over 3. No, nice and simplified without doing
Wait, where
too
did
much
you-
multiplication. So instead of multiplying 3 times 2, I just cancel the 2's.
No, but you get the 3 over 2 by simplifying the 18.
The 3 times 2? Wait, oh, you mean the 3 root 2?
Yeah.
Yeah, that came from the
Yeah, but don't you have to multiply the...
square root of 18 is 3 root 2.
Yeah, then what happens to the 3?
Canceled it.
Oh, you mean before you did it?
Yeah, where were you when that happened?
I don't
Just,
know.
like,
We had this whole like
conversation
conversation.
I don't know where I
Then we had this like side note conversation too.
We were having like in-depth like
Yeah, like
talk
an
all the time.
in-depth conversation.
Oh, would you look at that? Johnny
those
Ride
were
being
parts
here.
just- you were just throwing.
No, they were. I was like my side note over here. That thing I just
Yeah,
erased.
for part of number 2.
Yeah, I mean, I was like, I
Yeah.
was like, but if it's this, yeah. You guys can go back and watch the video.
I don't understand how they missed it as well.
I don't know either. It was like a good 1 minute. All right, anyways.
It's, like,
So for this one, you're gonna have some sort of like simplify. You need to make sure you know your exponent rules and you know like what the negative exponents mean. You know what to do when you have quotients and you know what to do when you're multiplying. So the first thing I'm gonna do
I hate
is,
this.
since this is negative, I'm just gonna flip this whole fraction upside
Give her
down
a flipper
so I can get rid of the negative exponent. So it's gonna look like
Give
this,
her a flipper room.
and it'll now have a positive 1/2 exponent. So I just flip it upside down, and then I'm gonna simplify from the inside out. Try not to simplify from the outside in. For
What do
this
you mean?
question, if you were to do the 1/2 power of everything, it's gonna get really ugly, and you're probably gonna get stuck and not finish. So always simplify from the inside out. Remember, you get dressed inside, and then you go out.
Just letting you know, it's
You
not.
don't go out and then get dressed.
Just letting you know, it's
There you go.
y to the 7th power and not y squared.
These expressions.
Yeah.
Just so you
Oh,
know.
it's 7. That's what you're trying to tell me.
Yeah.
This is a 7. Got it. Thanks.
No worries, just you know.
Anything else I messed up?
I'm not
Yeah.
sure.
All right.
I
So
think you're good.
simplify. If you simplify the numbers in here first, so 2 and 8, you
1
can
over
cancel
4.
and get 2 and get 1/4.
Kimmy, do you want us to keep the 1 there? Like, is that like
So sometimes you have to keep the 1, like if everything from the numerator cancels, you have to keep the 1, and sometimes you don't. So I just put it there at the beginning because I don't know yet if I'm gonna need it. Now for the x's, which one's bigger, 1/2 or 5/2?
5 halves.
5/2. So what's 5/2 minus 1/2?
Take a
4
5
halves.
4.
4/2,
Which is
which
2.
is 2, and you're gonna put that down here
Wait.
because
Why down there?
if it's a negative, then you put it down below.
But he's not
If
Yeah,
the
but
bigger,
it's
the
bigger.
bigger ones
Yeah.
go on the bottom, like
Yeah.
wherever it was bigger, it goes on the bottom.
It's like if some small person punches you
Why?
and you take a little bit of the blow, so you lose a little bit of your
5
power.
halves is like 5 square roots of 2,
You know what I mean?
Mhm.
or square roots of x rather.
Yeah.
So the small person uses all his power to punch you.
And
then
like
you lose
1/2
power.
is like one
You
of
still have
them.
power.
Yeah.
So you just keep it. So if you
Yeah.
canceled this, you'd be
So
left
just
with
that
4
one.
You're
roots
still there,
of
but
2.
you have to
Oh,
go left.
oh, okay,
me and my
okay.
brother fight.
I don't know why that was making sense in my head.
Shh. Okay, and then
So there's a good
now we can do the y's. So 7 is bigger than 3, so we'll have 7 minus 3 is 4 on the top. And that simplifies the inside. There's nothing left to do on the inside. Now we just do the outside, which is a square root. So you're gonna square root everything in here. Now, with the exponents, you can just multiply. 4 times 1/2, that's 2. 2 times 1/2 is 1. But when you get to the number, you have to actually square root it.
Could be
So the
2.
square root of 4 is 2. It's not half of 4, it's the square root of 4. They just happen to be the same thing. But if it's like an 81 in there, you don't take half of 81, you say it's 9.
Oh yeah.
If it's not square rootable, so if it's like a 6 in there, then you would just write the square root of 6. It doesn't have to work out evenly. Okay, so keep that in mind too. Or maybe it's something that you'd simplify. So maybe if it was 18 in there, you'd write 3 root 2. So down there on the bottom you'd have 3 root 2. Like that. I mean, it's awkward, but you can have it. You don't need to rationalize denominators when you're taking, or when you have a square root of x in there. Okay, so you don't know that that's irrational. You don't know what x is. It could be rational. You only rationalize denominators when they're numbers. So just keep that in mind too. Number 4, are the function's inverses show y or y not? Okay, there's 2 ways to show that they're, well, there's 3 ways, sorry. 3 ways we can show that they're inverses. You can do any of the ways for this question. The first way would just be to find the inverse of f of x. Second way would be to find the inverse of g of x and see if they're each other. And then the third way, this is something I didn't really teach you in class, but I wanted to make sure that you knew, because I feel like
I hate these. I
you
never
might
know
see it
what-
somewhere. If you do the composition of functions with 2 inverses, you should get
So,
x.
So you would do like,
So if they're inverses,
so just do f of g of x.
you'll get x. Yeah, so you could do like Thog or Goff, and you should get x if they're inverses. So I just wanted to like mention that to you. You don't have to do that on the test or anything. I just wanted you to know in case you see it somewhere, because I feel like it might be like, it could be like on the SAT or something like that.
Oh, then you better say it's on a test.
No, like, but it could be somewhere. So,
I just like the whole fog and
well, we're gonna do those down here. So.
I never know what goes into what, so I just put
Well, we'll talk
random
about that in
names.
number 6, I guess. Okay, so what I'm gonna do is I'm just gonna pick one and find the inverse of it. So I pick G. I'm gonna try to find the inverse of G and see if it's this one. So the first thing you would do is just switch your function notation so that it's y
Wouldn't
instead of
that
g of
be
x.
easier?
I feel like we didn't do a lot of these, so I just wanted to
That's true.
do that one. Like we didn't do one that looked like this, we did some that looked like f, so I'm just trying to like mix it up. Then you're gonna switch x and y. Don't forget this step. This is an important step. And then you're gonna solve for y.
Whoa, wait, you did the other. I used the F one instead. Does it matter?
That's
which one
fine.
you
We'll see at the end. So I can subtract 2.
Would you just multiply by 3?
No, it's already being multiplied. It says 3 divided by y.
So you multiply by the reciprocal?
You have to multiply by y. You multiply by what's being divided. You don't multiply by something that's not being divided. That would be
I
redundant.
thought that, but
I am redundant.
Now you can divide by x minus 2. And so the inverse of g is 3 over x minus 2.
yeah, it's
You might be
Now,
right.
asking-
if that's equal to f of x, then they're inverses. So you'd say, yes,
They don't unbar.
g, the inverse of g is equal to f of x. If you go the other way, you'll see that the inverse of f is equal to g.
See,
Or
I did the other way because that one was.
now,
first
did you
one.
get that, or did you get something that looks like that? Because it's possible that you could get something that's
I got that.
slightly different.
I got the right answer.
Can you not erase the right side real quick? I'm almost done with it.
Okay, so if you go the other way, you get that. And it's you still get the same result. Yes, they are inverses.
Hello. Wake up. Hello.
What's all working out?
Oh, there it goes.
She's sleepy.
So what if one equals the other, like one inverse equals the other, but
Cute
it
person.
doesn't work that way?
That doesn't make sense. It's in either the inverse or it's not.
Um,
Yeah, it's not gonna work one way and not the other way. Okay, so for 5, you're finding some operations. So you're just adding, subtracting, multiplying, or dividing, and then 6 is the composition of functions. So first we will subtract f from g. So we have g minus f. All of g minus all of f. When you subtract all of f from all of g, you want to make sure that you distribute the negative sign, so that you get minus 3 plus 2x squared. And then if possible, you want to combine like terms. So we can combine the 5 and the 3, and that's kind of it. So we have 2x squared plus x plus 2. I didn't put domain on here, so you don't have to worry about that.
So far, all my answers are right on this, and I'm pretty surprised.
Now the next one says to add f to g. So we're going to take all of f, and we're going to add it to all of g. And all you need to do for this one is just add like terms. So again, we can add the 3 and the 5. And that makes 8. So you get
If
negative
the,
2x squared plus x plus 8.
If the x plus 5 was x minus 5, would you distribute the plus sign and wouldn't it still be negative?
Yeah, it doesn't do anything.
Okay. But like you would have to do that though, right?
I don't do that. But in theory.
Okay.
The only reason we distribute the minus sign is because we want to make sure that we subtract 3 and we subtract negative 2x squared. And if you don't say that in your head, then you're going to get it wrong. You're just going to wind up subtracting 2x squared.
You're
instead of
adding
subtracting
negative 5
negative.
anyway,
you.
so it's the same thing. Okay, that makes sense.
And then the last one, you're taking all of f and multiplying by all of g. So for this, you have to FOIL. So we're going to distribute the 3. So 3 times x is 3x. 3 times 5 is 15. Then we're going to distribute the negative 2x squared. So negative 2x squared times x is negative 2x cubed. Negative 2x squared times 5 is negative 10x squared. And there's nothing we can combine, but I'm going to rewrite this in descending order just so it looks prettier. Because it annoys me. There you go.
Which question is gonna be from previous tests?
Be surprised.
There's 4 or
You'll
5.
figure it out.
No, because I mean like all of them are. There's not like a box that says like, oh, look at your.
I know, I'm gonna take one off.
Oh.
And or combine it with another one. It's horrifying.
It'll
be a surprise.
When you did those piecewise functions,
Oh,
none
yeah.
of us knew what to do, so we all just drew circles and lines on our graphs.
Yeah, you weirdos.
I really still don't know what a piecewise function is.
I don't think
How
none of us
many
did that
chapter
correctly.
2?
Yeah, that is
Are you
chapter
gonna be a
2.
piecewise
So
function?
that's not gonna be
I'm
on
just
this
gonna write,
test.
I don't know it.
Probably not.
I
Good
don't want to
deduction.
study
Alright,
them,
so
they're stupid.
just write this is the definition of f of g of x. The composition when you take g and substitute it into f's x. So these are 2 different ways of saying the same thing. Do you see that? Okay, so with the little bracket things or the parenthesis things or whatever, these 2 things mean the same thing. What you're going to do is substitute g into f. This is f. See how g is in f?
Yes.
Okay, so we're putting g in f. This is f. Hello, f. We want to put g inside of it. We're going to take it and we're going to put it right here. Like that.
You would square the x plus 5 first, right?
You would square the x plus 5 first because you have to do exponent.